Welcome to the DIY Honda Garage channel. The diagnostic trouble code DTC P0101 indicates a performance problem within the mass airflow MAF sensor circuit. The MAF sensor is a crucial component in the vehicle's engine management system as it controls the amount of air intake into the engine. This ensures the optimal air-fuel mixture for efficient combustion. The MAF sensor's location is generally found in the air intake system, typically right after the air cleaner, which allows it to assess the incoming air that will mix with fuel in the combustion chamber. An issue flagged by this code often indicates that the MAF sensor is unable to provide accurate readings of the air entering the engine, leading to potential engine performance problems. Proper function of this part is essential, as any discrepancies can affect fuel economy, power delivery, and emissions. The DTC P0101 pertains specifically to the MAF sensor's range and performance. This sensor directly measures the volume of air entering the engine, which is vital for the engine control module, ECM, to calculate the precise amount of fuel needed for combustion. Typically located just after the air cleaner, the MAF sensor plays a crucial role in ensuring that the engine runs efficiently and smoothly. If the MAF sensor malfunctions, it can send erroneous signals to the ECM, leading to an incorrect air-fuel mixture. The resulting performance discrepancies can lead to various symptoms, including poor acceleration, rough idle, and increased emissions. In cases where this code is present alongside other DTCs, such as P2073 or P2228, those should be addressed first to ensure a comprehensive diagnosis. Several potential root causes can lead to the triggering of DTC P0101. First and foremost, damaged wiring or poor connections in the MAF sensor circuit can prevent the sensor from delivering accurate readings, potentially causing the ECM to miscalculate the air-fuel mixture. Another primary concern is a faulty MAF sensor itself, which could either be worn out or internally damaged. Additionally, leaks within the intake system, such as in the intake air duct or connections, can lead to the sensor measuring incorrect airflow, thus affecting performance. Other contributing factors may include obstructions in the air cleaner or even debris in the intake system, which can impact airflow and the sensor's operation. Addressing these elements early in the diagnosis can help pinpoint the underlying issue efficiently. When DTC P0101 is triggered, several recognizable symptoms may manifest in the vehicle's operation. One of the most common issues experienced is poor engine performance, including a lack of power during acceleration. Drivers may also notice decreased fuel efficiency. This is primarily caused by the incorrect air-fuel ratio, leading the ECM to adjust fueling incorrectly. You may experience rough idling or stalling during low-speed operation, indicating that the engine isn't receiving the necessary air intake. Additionally, warning lights on the dashboard may illuminate, prompting the driver to investigate further. These symptoms collectively indicate that the vehicle is not operating at optimal efficiency and can lead to further issues if left unaddressed. The first step in troubleshooting DTC P0101 involves a thorough inspection of all relevant components to ensure they are in acceptable condition. This includes examining the positive crankcase ventilation, PCV, valve and hose, the intake air duct, the air cleaner, and the purge line. The connections through the turbocharger joint to the throttle body should also be assessed. Poor connections or visible damage can lead to erroneous readings by the MAF sensor and affect engine performance. If any issues are identified during this phase, repairs or replacement of the damaged parts is necessary before proceeding to the next diagnostic step. This comprehensive inspection helps eliminate potential causes early, ensuring a more efficient troubleshooting process. In the second troubleshooting step, focus on the intake air duct, specifically at its connection to the air cleaner. This visual inspection is critical, as any damage or looseness can result in unmetered air entering the engine. Such discrepancies can skew the readings provided by the MAF sensor, leading to performance issues. If the inspection shows that the intake air duct is intact and secure, you can move on to the next step in the troubleshooting process. Alternatively, if you find any damage or looseness, it's essential to either reconnect snugly or replace the duct to restore proper functionality. Completing this step effectively reinforces the integrity of the air intake system and prepares it for further analysis. The third step requires a visual examination of the air cleaner element to determine if it is dirty or clogged. A dirty air cleaner can restrict airflow significantly, which can subsequently interfere with MAF sensor readings. Ensuring that air can flow freely is vital for the engine's performance and efficiency. If the air cleaner is found to be excessively dirty or clogged, replacement is necessary to restore optimal intake air levels. Conversely, if inspection shows that the air cleaner is clean and acceptable, the troubleshooting steps can continue accordingly. It is important to note that maintaining a clean air cleaner element is crucial, as it not only affects MAF performance, but also engine longevity. The fourth troubleshooting step involves checking the signal from the MAF sensor while the engine is off, which facilitates a controlled analysis of the signal. At this stage, the Honda Diagnostic System, HDS, is employed to assess the MAF sensor signal. The expected parameters should fall within a specified threshold, typically in Hertz, H. If the observed MAF sensor readings are not within the acceptable range of 520 to 10,000 Hertz, this could indicate a fault in the MAF sensor or its associated circuitry. If the readings are normal, you can proceed to the next diagnostic step. However, if there are abnormalities in the values, it is advisable to replace the MAF sensor or the intake air temperature IAT sensor, as they may be directly affecting performance. In the fifth step, a live analysis of the MAF sensor signal is taken when the engine is running. Start by balancing the engine at idle, and then utilize the HDS to observe the parameters. The focus is again on the Hertz, HZ, values, which should align with the bandwidth of 520 to 10,000 Hertz. If the current signals fall within the appropriate threshold, this suggests that the MAF sensor is functioning correctly while the engine is operational. However, if any discrepancies arise in the readings, this points towards a malfunction in the MAF sensor or possibly the IAT sensor. Replacement might be necessary. This step is pivotal as it confirms whether the sensor is performing correctly under typical operating conditions. The sixth troubleshooting step takes a more comprehensive approach to verify if the problem persists after any necessary repairs. Activate the vehicle and switch it to on mode before utilizing the HDS to clear existing DTCs. Following this reset, start the engine and hold the RPM at around 3,000 without load until the radiator fan engages. Then let it idle for at least 5 seconds. The next phase involves driving the vehicle at 37 miles per hour for a duration of at least 5 seconds to ensure full operational assessment. Upon completion, recheck for any pending or confirmed DTCs with HDS. If DTC P0101 reappears, it confirms a recurring issue. Finally, if no codes are present, it suggests that the system is currently operating correctly. indicating that you should check connections and ensure everything is secured properly. The final repair verification step is crucial in ensuring that all preceding troubleshooting efforts and repairs have addressed the root cause of DTC P0101 effectively. After clearing the DTC and performing necessary repairs, it is essential to evaluate the vehicle's performance under typical driving conditions. Observing how well the engine runs post-repair can indicate whether your interventions have corrected the problem. Check for any remaining DTCs to ensure that all faults have been adequately addressed. It's also wise to monitor for any changes in engine performance, such as improved acceleration and reduced emissions. This step acts as the quality assurance phase of your diagnostic efforts. Preventive maintenance plays a vital role in minimizing the recurrence of issues related to DTC P0101. Regular inspections of the air intake system help ensure that components such as the MAF sensor and air cleaner remain in good operating order. It's recommended to replace the air cleaner element at regular intervals, as a clean filter is essential for optimal airflow to the engine. Additionally, routine checks of sensor connections and wiring can help identify any signs of wear or damage before they escalate into more serious issues. Implementing these preventive measures can significantly reduce the risk of future DTC occurrences and enhance overall engine performance. Proactive maintenance not only saves you time and money in the long run, but also extends the life of your vehicle. In summary, DTC P0101 indicates a MAF sensor circuit range and performance issue in the Honda Accord. A systematic approach to troubleshooting, including checking connections, inspecting the intake air duct, and monitoring the MAF sensor, is essential for identifying the root cause. If the sensor fails to perform within specified thresholds during diagnostic checks, replacement may be necessary. Regular preventive maintenance, such as timely air cleaner replacements and thorough connection inspections, can help avoid similar issues in the future. By staying proactive and attentive to the vehicle's performance, you can ensure a more reliable and efficient driving experience. Implement the outlined steps and recommendations to address potential problems effectively. Please like and subscribe to the channel. See you next time.